So far, let's review a little bit. We have learned two methods of factoring polynomials. What was the first one that you have to always do before you do anything? Lynette? Thank you. We have to factor out your GCF first, right? Before you do anything, right? Every time I give you a factoring problem, this is what you have to do first, right? This is one of the easiest way, right? And what's the second method we learned? Chuck?
Difference of two squares.
Difference of two squares is correct. So it looks something like this, right? A squared minus b squared. We learned that if you have a polynomial that looks like something squared minus something squared, that's why it's called difference of two squares. This always factors as a plus b times a minus b. Is that right?
Yep.
Now, do all polynomials look like a binomial? No, it doesn't. Of course not. So we're going to today learn a new method. Okay, are you ready? Good. People. So today our method is going to factor something that looks something like this: x squared plus bx plus c, where b and c are some number. I'm sorry?
What about
X is some variable. So x squared plus bx plus c. Today's topic is this form. Okay, we're going to be able to factor this sort of polynomial when we have this. Okay. Dana, did you have a question? No, you have to know. Yeah, so yeah, on the test, I'm not going to tell you, oh, do use this method. You have to, when I give you a polynomial, you have to just be able to factor. Yes.
And so on the test, we can use any formula.
Yeah. But are you going to use difference of square for things with three terms?
No.
Of course not. Okay, so you should know, right? Difference square is only if it works with if you have difference of squares. Okay, you have to have binomial, right? They have subtraction in the middle, and then right squares of the first two terms, first and the last term. But so we're done with this, right? If I show you how to factor this trinomial, then we could factor every trinomial, correct? No. This is a special type of a trinomial. Why do I say that? What I'm telling you is, just because you know how to factor x squared plus bx plus c does not mean you could factor every trinomial. This is a special type. Why do I say this is a special type of a trinomial? Which makes it sort of really easy to factor. In other words, does this represent every trinomial you could write? It doesn't. Why not? Who could tell me? Yes?
Oh, because some trinomials are x squared plus bx plus b squared or c squared.
Not quite. No, that's not the reason. Not quite. Anybody see the reason why? Dana? No, you could always write every polynomial as a standard form. Somebody give me a trinomial. Just any trinomial. Yeah.
4 plus y squared.
Okay, good. Now, but does that mean that, let me give you a hint. Look at the quadratic term. This trinomial is special because of this quadratic term. In other words, the one with x squared. What is this coefficient, guys? 1. So we're only dealing with the simple one where the coefficient of the quadratic term is 1. Do you always have to have 1? No, right? Some quadratic, right, equation could have some other number other than 1, right, as a coefficient. But today we're only going to factor trinomial that has 1 as the coefficient for the x squared. That's what makes it easy. Does that make sense? Of course, as we go on in this section, we're going to learn where if it's when this coefficient is not 1, we're going to show you how to factor that. Does that make sense? But today, please understand that we're doing a special case, okay? Does that make sense? And this special case is really easy to factor. Some of you probably know this from intro also. Is this okay? Do you see where we're going with this? All right, let's move on. So write this down. This is our topic 5.7, factoring pattern for 1, x squared plus bx plus c. Okay, so that's what we're working on. You don't need to write this down, but I wrote it down. Only trinomial with coefficients of the quadratic term is 1. That's what we're working on. So please don't think that we're talking about any sort of, we can't factor any trinomials yet. Okay, we can only factor now after today. You can only factor trinomials with 1 as its coefficient in the quadratic term. Okay? Aiden, did you have a question? Yeah. Oh, right. We're going to skip 5.6 for now. We're going to come back to it later. So we're gonna do 5.7 today. Very good. Okay. All right. So let's do an example one. Example one. What would the instruction say? Am I gonna say factor this? No, it's already factored. Yeah, I'm just gonna say simplify. In other words, I want you to go forward, right? Just multiply it out. Do you think it's a good idea to change this to addition?
Yes.
Yeah, okay, go ahead. Everybody multiply it out. This is sort of a review, and you'll see why I'm doing this in a minute. Okay, go ahead. Sort of this review, warm up. Multiply this out, okay? Of course, change it to addition, okay? So you don't make silly mistakes. All right, so did you all change it to addition like this? X times x, class, what is it? X squared. What's x times -4?
Negative 4x.
And then -6x plus -6x, right? So I should put plus. Okay, so did you all get this? X squared minus 10x plus 24. Easy?
Yeah.
Okay, so what we're trying to do today, notice this trinomial. What is the coefficient of this x squared? 1, right? So we're going to try to go backwards today. That's what we're going to do. So today, if I give you x squared minus 10x plus 24, you should be able to rewrite this as x minus 6 times x minus 4. So we'll show you how to do that in a minute. Right now, I haven't explained how to do that yet. But anybody see anything interesting in terms of the two numbers that we had? -6 and -4? By the way, do you see why we have to have x and x here for these two binomials? When you multiply binomials, what do you get? What's your product? Most of the times, it's always going to be a trinomial. When is it going to be a binomial? When you multiply binomial times binomial. Yes, sir?
When it's like x, or no, a plus b times a.
Yeah, when they look exactly like, but one of them is addition, the other is
Subtraction.
subtraction. So Brandon is right. If it's a plus b times a minus c, then it becomes binomial. But all the other times, when you multiply two binomials, it's going to be a trinomial. Would you not agree? Okay. So I want you to notice something interesting about -6 and -4. What's -6 times -4, guys? Positive 24. What's -6 plus -4? Negative 10. Kind of interesting, don't you think? Anyway, hold on to that thought. Now, I'm going to show you another way of multiplying these two binomials. Is that okay? I like to do it vertically. Okay, so what I mean by that is, let me try to hide this. Hold on. So I like to multiply this vertically. Let me show you that if I multiply this vertically, you will get the same answer. So I'm going to write this x plus -6 times x plus -4. And of course, it's the same way. Instead of doing like arrow, I'm going to do this way. X times x, right? Isn't that what I'm going to do first? Isn't that what I should do first? What do I get when I multiply x times x, guys? X squared. And I'm going to do this in red. Now I'm going to multiply x with what? -4. Just like how I did it with on the other one, right? Only difference is I'm just doing it vertically. Do you see that? So here, then I get x times, so I get plus, of course, everything. I change everything to addition, so everything's going to be addition between each term is going to be addition. So x times -4 is -4, x. Would you not agree? Then, of course, I'm going to multiply -6 with what? X. Plus -6x. And lastly, I'm going to multiply -6 and -4, which is plus 24. Do we get the same answer? We get x squared plus, what's the middle term? -10x plus 24. Would you not agree? Which is the same as what we had before. Isn't this the same? Now, I like this vertical method because it's sort of nice to see how you could get the first and the last two terms. All you have to do is what? Multiply the... How do I get the x squared, the first term? Yeah, just multiply straight down. If I multiply straight down, that's how I get the first term. What about the last term? Straight down, right? That's how I get the last term. What about the middle term? How did I get the middle term? You do the cross. When you do the diagonals, when you do the cross, that's how you end up with the two middle terms, and then you add them together, because those will be like terms. The reason why I did this is because it's easy to see how you get the middle terms this way. Does that make sense? Right? If I do it this way, it's sort of confusing. But if I do it vertically, you can see that the cross will give you the middle term, and then all the vertical ones will give you the first and the last term. Is that okay? Is that okay? So knowing this, we could actually factor these trinomials with the coefficient of the quadratic term to be 1. Okay, if the leading coefficient is 1, we could actually factor this. Watch this, okay? Okay, take a look at this example. As you can see, my leading coefficient or the coefficient of the quadratic term is 1, right? 1x squared plus 16x plus 28. You see that? Okay. So if I have this, I know that this must be a product of two binomials. Would you not agree? And the two binomial must have what in front for the first two? X. Would you not agree that I have to have x and x there? Right? Isn't that how you're going to get x? Isn't that how you're going to get x squared? Is there any other way to get x squared other than x times x when you have two binomials like this?
No.
Actually, there is. There are some. What? You could have? Yeah.
You can have x in parentheses and plus.
No. When you have two binomials, you're going to have to multiply two binomials, right? So you have to have x in both of these terms. Well, you could have. Are there any other way to get x squared other than x times x?
No.
Yeah, there is. There is, guys. Come on. Yeah, what do you think?
X to the fourth divided by x squared.
No, we're multiplying these two binomials together. We're not dividing. Yes.
X squared and 1.
X squared and 1, but then you would not have a binomial. Then, because you would have number here, you have another number here, you would add them together. Then you're not gonna have a binomial. Anybody see how you could get x squared other than x times x? Yeah. Exactly. Can I do negative x times negative x? Wouldn't that give you x squared? Right? So that's one case. What's another case other than x times x? You could do negative x times negative x. Or you could also do 2x times what would give you x? Half x. Couldn't you do that? Or 3x times 1/3 x. We could do that, right? But it turns out when we do these factoring, okay, we just want integer coefficients. Is that okay? And we want integers to be filled here. So don't worry about the x times x. Don't worry about the negatives yet, okay? So just think about the easiest case. How do you get x squared? Well, there are many other ways, but we're just going to use the easiest way, x times x. Now, all we have to do is then, we just have to get the two numbers that goes here, guys. That's it. Is that easy? So all we have to do is figure out those two numbers that goes here so that it multiplies to what? 28. Isn't that how we get? Remember when we multiply vertically like this, right? From top to bottom, x times x will give you the first term. Whatever these two numbers, right? We multiply these two numbers, it gives you the last term, right? So that kind of narrows it down because how many ways are there to multiply two numbers so that you get 28? There's only one way? What's the easiest way? Let's start with the easiest way. Yes?
28 times 1.
28 times 1 is the easiest way. If you could have 28 times 1, what else could you have? Negative 28 times? Negative 1. So that's another case. Do you guys remember doing something like this from the very beginning of this chapter? Where they ask you to write down the pairs of factors of a number or so, something like that, okay? Okay, so is that all?
No.
What about 2 times 14? If you could have 2 times 14, what else could you have?
Negative 2 times
Negative 2 times negative 14. Am I done?
4 times 7.
You could have also what?
4 times 7.
Okay, does 3 go into 28? No, because you could add 2 and 8. It doesn't, right? Does 4 go into 28?
Yeah.
Yeah, how many times? 4 times 7, doesn't it?
Negative
If I could have 4 times 7, of course I could have also negative 4 times 7. And of course 5 doesn't go in, it doesn't end with 0, 5. 6 doesn't go in, right?
7 does.
7 does, and it sort of wraps around. So you stop. That's when you know when you stop, right? It sort of wraps around, right? So you have choice. You have 6 choices to choose from. Which one of these pairs do you think will fit? So that, what's the important thing? So that you're, because I could have chosen any of these 3 and I get 28 when you multiply vertically, right? X times x, whatever times. But what has to be true for this, Aaron? When you add the middle terms, it has to add up to, which is 16x. It has to be, right? So if I were to plug in 1 and 28, would it work? How can you see this quickly? All you have to do is, how do you get the middle term? Do you guys remember why I wrote it vertically? Isn't this how we get the middle term? And we're just looking for a number. When you do this, the middle term comes out to be 16x. Do you see which order pairs will work here? Bella? 2 and 14. How many people agree with Bella? How many people have different idea? Okay, she is correct. It is 2 and 14. Could I write down 14 and 2? Does it matter? No, you still get 16. Let's check. What do you get when you do multiply x times x here, like this? X squared. Then when you get x times 14, you get 14x plus 2x. And then you get, again, vertically, 2 times 14. That's how you get the last term. Do you see why I wrote it vertically? it's really easy to check how you get the middle term. You do the cross, right? When you do the diagonals, right? That's how you get the middle term. Do you see why we're doing this? And later, not only would it help you to do this one also, when this coefficient is in 1, right? This method is going to be helpful for us. Does that make sense? So that's why I'm showing you this way. Right? Are we good? So we're basically looking for when the two numbers, right, multiply, you get the last term, and then when you do the diagonals, you get the middle terms. Is that easy? So what's the answer? How do I factor this trinomial? What's the answer? The answer is right there, guys. What's the answer? What's the answer? How do you factor this? X plus 2 times?
X plus 4.
Exactly.
Can't you just add the factors or something and then add the
Right, so it turns out these two numbers, when you multiply, you should get the last term, and when you add, you should get the coefficient of the middle term. But that only works if the first coefficient is 1. If it's not 1, you can't think it that way. That's why I'm showing you this way. Okay, so this will work for other general trinomial later. Okay, so keep that in mind. Yes, question? So do you see my answer? I circled my I boxed my answer. It's x plus 2 times x plus 14. Is there a way to check this? Yeah, you just what? Multiply them out, and you should get x squared plus 16x plus 28. But didn't we just check right here? Didn't we check that the first term became x squared? That checks. Last term became 28. That checks. What's 14x plus 2x? 16x. Didn't it check? We just checked it. See, this way you could actually check and get the right answer also. Do you get the idea? Okay, may I go on to example 3? All right, here we go. Let's try our next one. Does this fit the pattern that we just talked about, where the leading coefficient is 1? Yeah, it's y squared, so it's 1y squared, isn't it? So we have y squared minus 9y plus 8. By the way, can I just write this as an addition, the middle term? No?
Oh yeah.
Okay, yeah. So here you go. Okay, it's not a big deal. So, we're gonna do this vertically again. Guess what has to go into, by the way, it has to be binomial times binomial, right? That's how you get a trinomial. So what must be the first two terms of these two binomial if you have y squared, guys? X? Y, you need y, not x. So you got y times y. There you go. Now, so before we get going, we have to look at all our possibilities, right? In other words, how do I get 8? How many ways are there to get 8 when you multiply two numbers? What's the easiest one? 1 and 8. If you could have 1 and 8, what else could you have?
2 and 4.
Oh, no. If you could have 1 and 8, you could have, okay, don't forget the negatives. Sometimes the negatives will work out too, okay? Be careful. And then what about, because if you forget the negatives, then you don't have all the, what about 2 and 4? Are there any other? Go ahead. I want everybody to then figure out, there's no other, right? Figure out what goes into these, right? Binomials. These two numbers. Which two numbers do we need to choose? Go ahead, I'll wait. You guys think about it. So I'm basically looking for, when I do the cross, right? Out of these pairs, right? I know that these pairs multiplies to 8, so I don't have to worry about, right, the last one being 8. But when I do the cross, it should equal to what? 9 or negative 9y? Negative 9y. Does anybody see which pairs we will need here? How about Song? What do you think? 1 and 8. Okay, let's plug in 1 and 8. Song, what's 8 times y? I mean, y times 8. Let's check and see whether we get 9y, okay? What's y times 8, Song? 8y. What's y times 1? So when you add them together, do you get negative 9y? Uh-oh, so this doesn't work, does it? Do you want to change your answer? Yeah, it should be negative 1 and negative 8. That way, if you do that, right, when you do y times y, don't you get y squared, guys? And then you do y times negative 8, isn't that negative 8y? And then negative 1 times y, you get negative y. And then, of course, lastly, negative 1 times negative 8, you get 8. Does it check? What's negative 8y plus 1y?
Negative 9y.
Negative 9y. See, we got all three checks, right? 3 of them checked. Therefore, there's your answer. Y plus 1 times y minus 8. Do you see how this works? Is this pretty straightforward? Okay, can you do something like this for your homework? Of course, do you think they're going to give you these simple ones? Or are they going to get creative? Yeah, they're going to get some. Okay, so let's see. Let's try some of those, okay? Example 4, this is not that creative, but it's sort of, because, do you think why do you think I said it's a little bit creative here? It's not that much, but they give you the, look at the last number. It's 42.
Oh, see.
So, yeah, like you have more, yeah, more work, or you have more possibility to get 42 when you multiply two numbers, right? But that's the only thing. So let's just do that. That's the hardest part, really. So what is then the, what's the easiest way? Whoops. Before I show you the answer. What's the easiest way to, we know it's going to look something like this, right? What's the easiest way to get 42? 1 and?
42.
42, that's positive 42, right? What's another? If you could do 1 and 42, you could also do negative and negative 1 and negative 42. And then you could have 2 and 17 and what else? Negative 2 and negative, you said 2 and 21, isn't it? Not 17. Yeah, 2 and 21 and negative 2 and negative 21. And then does 3 go into 42? Yes. What's 4 plus 2? 6. And 3 goes into 6. 3 and what, class? 14. Which if that's true, then negative 3 and negative 14. This is the hardest thing that you gotta do. What other do we have other? Does 4 go in? 4 does not go into 42. What about 5? What about 6? Okay, 6 and what? Okay, so if you have 6 and 7, what else could you have?
Negative 3 and negative 7.
Right. Now, if that's true, then it sort of wraps around, right? It wraps around, so you stop there, right? Because after 6 is 7. Well, 6 times 7 is 42, so it wraps around. That's when you stop. Is that okay? Now, we know it's going to be, if you have p squared, right? It's going to be a multiplication over two binomials, right? So what are you going to have? P and P there, right? Hello? Does that make sense? Of course, it's going to be, I want you to write always plus here. Then what do we need here? So that we get what we need. Of course, please remember, the middle term is going to be where you do that cross, right? Oh, a lot of you see already? Pretty straightforward. Matthew, what do you think? Negative 3 and negative 14. How many people agree with Matthew here? Would that give you negative 17 in the middle term? Yes, it will. Look, what's p times negative 14? Negative 14p. What's p times negative 3? Negative 3p. What is negative 14p plus negative 3p? Yeah, see, look. And of course, is that all? We gotta, of course, check the vertical ones, right? Of course, p times p is p squared. What's negative 3 times negative 14? 42, right? And that's how I got negative 3 and negative 14. You guys remember that? Right? So you should all check all these three things, but really, especially the middle term, right? That's what we have to be careful of. So what's the answer, class? The answer is right there. What's the answer? P minus 3 times P minus 14. There you go. Okay. Easy enough?
Yes.
Can you do something like this? All right, let's try example 5 then. Good, we're moving right along. Here we go. Try example 5. It says m squared minus 3m plus 5. And you know what? This one I'm going to have you do all yourself, okay? M squared minus 3m plus 5. Go ahead, everybody try. Okay, so you guys are asking good questions. We can't use 5s. So we know it's going to look something like this, right? M, right, plus something. First of all, let's look at the factors of 5, right? How can we multiply two numbers and get 5? Well, there are not that many choices, right? What? 5 and? 1 or what else?
Negative 1 and 5.
That's it. Are there any other? No, that's it. Okay, so it's gonna have to. Let's just try the first one. Let's say that we did m plus 1 times m plus 5. Okay. Oops, what's going on? Oh, give me a sec. Okay, here we go. Does this work? If I do m plus 1 times m plus 5? No. Right? Because look at the middle terms. You see why it's sort of nice? You could just look at the cross, right? The diagonals. You get 5m, you get 1m. What's 5m plus 1m? 6m. It's not negative 3m. So it must be the other one, right? This one doesn't work either. Because what do you get if I use negative 1 and negative 5? You get negative 5m and negative m. That doesn't equal to negative 3m. It equals to negative 6m, right? Wouldn't it be great if it was negative 6m or something like that? Or right? But it's not. So guess what? Could we use like some fractions? No. For these, I want you to use only integers. Because if you start using fractions, there are infinitely many ways of multiplying two numbers to get 5. Okay? So we only use integers. So guess what? Turns out this one is a prime polynomial. Okay. In other words, not all polynomials will be factorable. This one you can't factor. Okay? So but you can only tell this is prime polynomial only if you tried everything. If you skip one of them, right? It's not. You have to try every possible combination. Okay. So as you can see, this one was easy because why? There were only 2 possible ways to get 5, right? But imagine if this number was not 5, but like the other one, like if it was like 42 or something. How many of these did you have to try?
6.
No, you have to try 8 of these. Does that make sense? Right? But I mean, you don't have to really plug it in. You could sort of see, right? Does that make sense? So the hardest problem that I could give you are these prime polynomials, because that would require you to actually try every possibilities. Does that make sense? Because if you don't, what if the one that you skip is the one that works? You see what I mean? Right? So in order to know for sure whether or not the polynomial is a prime polynomial, you gotta try every possible way. Is that okay? Does this make sense? All right. So for that is what? What do you write, guys? Prime polynomial. You can't factor this, okay? Because we tried every possible way to get, right, 5, and it doesn't work, right? -1, -1, -5 doesn't work. 1 and 5 doesn't work. Okay, does that make sense? Again, this was sort of a nice one because it was the last number was 5, right? Okay. All right. Let's move on to the last one then. So this is how they get creative. Remember I told you they get creative? X squared minus 4xy plus 4y squared. Why do I say this one is sort of creative compared to the other one?
2 variables.
Yeah, you now have 2 variables, but it turns out it's nothing more than, first of all, in order to get x squared, and we have to have binomial times binomial, right? You have to have what in the first 2 terms? X squared, x and x, right? To get x squared, correct? Guess what you would have to have for the last 2 terms to be y squared, guys? Yeah, you have to have y here and y here. And how many ways are there to get 4? Well, there are 4 possible ways. 4, 1, 4, whoops, -4, -1, right? 2, 2, -2, -2, right? So all you have to do is figure out what goes in here, because look at my middle term. It has 2 variables, right? The one from the first term and the one from the last term, right? Because when you do this, isn't that how you're going to get x and y there? You understand? So don't be alarmed when you see the last term with some variables, right? Squared. You just have to have that variable there at the end. Does that make sense? Now go ahead and figure out what number you need in there, okay? Go ahead. Who's got the, Michael, what did you get? -2 here, and what else? -2. How many people agree with Michael? Raise your hand. Okay. Would you not agree? Because it's easy to see. What's x times -2y, guys? What's x times -2y? -2 xy, because you have the 2 variable. What's -2y times x? -2 xy. When you add them together, what do you get? -4xy. Does that make sense? So, do you see how it checks out? And there's your answer. And by the way, how come I wrote it this way? X minus 2y whole thing squared.
Oh, because it's the same.
Yeah, they're the same binomial. Could you have written twice if you wanted to? Yeah, but is it okay if I write x minus 2y squared? Right? I think this is a little bit simpler than writing it twice. Isn't that right? Of course, it takes you less work. Does that make sense?
Yeah.
Do you see why I told you x minus 2y squared does not equal to x squared minus 2y whole thing squared? Right? It equals to a trinomial, doesn't it? Yes, Jason.
-4 or -1?
-4. Does -4 or -1 work? Let's plug it in. That's a good question, guys.
Oh wait, I see.
Okay, do you see why it doesn't work?
Yeah.
Any question? You understand? Can you do something like this for your homework?
Yeah.
Good.